What's up, guys and gals? Welcome to Mindful Math. Today we're going to talk about factoring by grouping. So this is not the most efficient way to factor quadratic equations, but it is a way that will work with any quadratic equation. Actually, that's not true. As you know, there are many quadratic equations that cannot be factored, or at least not with integer coefficients, so that's not particularly helpful for us. But this method works really well when we have our a term that is not 1. And again, that's with that method of ax squared plus bx plus c. That's just the number in front of the x squared. So you can think of it as a, or you can just think of the coefficient of the x squared term, or just the number in front of the x squared. There's no reason why you have to memorize all of these names. But as we go through this, I want you to think of any other names that you can call this. So there's no particular reason it has to be factored by grouping, and that will help you remember the key steps of it if you can come up with a different name. So again, this is probably the most complicated way to factor an equation, but it works with every quadratic that you need to factor. My mom was a chess teacher. She was coach of our chess team. I was the captain. I know it was really tough. Got way too many dates. But one thing that she always did is she taught everyone how to checkmate with a rook and a king before how to checkmate with a king and a queen. And that's because it's more difficult. Because if you can do it with a rook and a king, you can, of course, do it with a king and a queen. So this is the same way. If you can factor by grouping, you'll be able to factor anything that you need to factor. All right, so let's go ahead and let's get after it. So the first thing we need to do is multiply and find AC. Well, what is A and C? Just the first and last numbers. So in this case, 5 times 2 is, of course, 10. Then we need to find two numbers that multiply to 10 and add up to 11. So in this case, of course, we're going to have 1 and 10. So most of the time, it's going to be fairly obvious how you arrive at the pair of numbers that you need. In the case that it's not, think of ways that you could do it systemically to make sure that you could find the correct pair. So maybe you would list out the factors of that AC, of that 10 number, or maybe you'd think of all the possible ways we can add up to B. So whatever works best for you, if you're having trouble finding it and it's not apparent right away, think of how you can do that quicker. So after we do that, we split our 11x into 5x squared plus 1x plus 10x plus 2. So we're just splitting that middle term here. So instead of 11x, we're going to write 1x and 10x. And then we're just going to group these two and factor each one. So the greatest common factor of this term is just x. So I'm going to pull an x out here, and we'll have 5x plus 1 left. And on this side, our greatest common factor is 2. So we're going to factor out a 2, and we'll be left with 5x plus 1. Now, if we did it correctly, we should have the same thing inside the parentheses. And so if you think about it, we can factor out that entire parentheses. So if you think of this as just another variable, that whole 5x plus 1 term, we can factor out a 5x plus 1. And so we get 5x plus 1, and then we're left with, in the parentheses, x plus 2. And of course, if you were paying attention mindfully, which I hope you were, you'll notice that I made a mistake and didn't include that equals 0 as I copied it along. So we want to be mathematically correct here. And now we have a nice factored equation here, and we can go ahead and solve for x using our zero product property, and we'll get that x equals negative 2 or x equals negative 0.2. So this method, this factor by grouping, can be used for any quadratic that is factorable. So I hope you find this helpful. If you're ever stuck, if you can see the factors right away, go ahead and factor it out just using your head. But if you're having trouble, especially if there's a number in front of that x squared term, this is a great method to use. So what other names did you come up with instead of factor by grouping? I sometimes think of it as factor by splitting because we're splitting that middle term. You could think of it as double factoring, because we have to factor here, and then we have to factor the whole thing together. So let me know in the comments below what names you came up for this method, which most of us call factor by grouping. And if you found this helpful, please subscribe to the channel, and we'll see you next time.